Dear civil engineers, in this session we are going to design a column. Okay, so already we have analyzed, we have checked our model as our column is okay or not. Now we'll go for our column reinforcement calculation. Okay, so to check our column reinforcement, I'll select on column, and as per your requirement you can, I mean, in the same way you can also find out the required reinforcement. So I'm just selecting that on, sorry, I'll skip it, and taking all Storey from here, taking all Storey. I'll click here and I'll right click, or for that one, for all Storey, I have selected, and here I'll click show selected object only. You just see now only on column are available. Okay, so here we are seeing the reinforcement for on column, and if you will see here something, the reinforcement in bottom are less, and in our top floor, okay, in our top floor we need more reinforcement than bottom floor. So what is the reason of that actually? So this is the only one reason for unbalanced moment. Due to unbalanced moment, we are getting more reinforcement in top column than bottom column. So actually this is not an issue. To solve that, what you can do, that you can increase your column size, or you can increase your beam size, and after that you should reanalyze this. So I'm not going to do that. I will just only show you that how we'll maintain that situation. So to maintain this situation, you have to provide this reinforcement 3.4547. okay, you have to 3.4547 inches square reinforcement overall the column. Otherwise they have another solution. Just increase that column size, increase that column size. If I just go here, show all object, so just see for that column they have no issue, and for that column we're seeing here more reinforcement required for that side and that side. Okay, they have some reason, because in top it's taking more moment than bottom. So now if I take that column here from that column, so here I'll take all Storey and I'll select like that. Here all column have been selected, and now right click and show selected object only. And if we see here, they have no more reinforcement required in top floor than bottom. Everywhere here, everywhere we are getting how much percent of reinforcement. We have to check here, display design check, and the rebar percentage apply. See here 1% reinforcement. Our that column taking 1% of reinforcement overall over the section. Okay, so to find out the number of reinforcement, how much required, it's 3.15. So I personally prefer for design, I mean for construction purpose, or when they have no supervision of site engineer inside, so we need to increase the reinforcement little bit. Okay, so here 3.15, I'll consider that reinforcement as 3.5. That's it, 3.5 inches square. That's okay. Now I'll go to here for that Excel sheet, and I have another Excel sheet to find out the required reinforcement, and you will get that reinforcement in resource file. Okay, so you can download this Excel sheet. I'll just go here for column. Okay, so first of all, longitudinal reinforcement column, and I'll take another thing, the torsional reinforcement for column, is it required or not? Apply. So no torsional reinforcement is required here. Okay, so it's done. And one thing, column interaction ratio, if we just go for it, it's also okay. They have no issue with it. Now just longitudinal reinforcement, and here I'll provide 3.5. and if we provide 20 mm rebar, okay, 20 mm rebar, then we need number 8 bar here, number 8 bar, and the provided area will be 3.89559 inches. So that means this is more huge, I mean more than our existed value. So what we'll do actually here, I will use that box. I will use for 20 mm, and here I'll provide the required reinforcement. What is the required reinforcement? 3.5. okay, so 3.5. if I provide and 6, and here if I provide number of 6, I mean 20 mm 4 bar and 16 mm 6 bar, then what is the provided area? Here 3.8 on, almost same, but here we're getting little, I mean less reinforcement of that, less reinforcement of that 20 mm 8 bar. So if I provide number 6 20 bar and 2 16 mm bar, then it's okay. So it's not okay actually, sorry, it's okay. Just see 3.54. so this is okay if we provide this way 3.54. and if we go for economical design, or if we think about economical design, then economically we have to check it. Okay, so you have to find out that what is the price of that 20 mm 6 bar and 16 mm 2 bar. And another way, you have to check that what is the difference between if I provide 2 20 mm and if I provide 8 16 mm, then what is the difference between them? So I'm seeing here 3.46. actually it's also okay because we need 3.15 and we are getting 3.46. so if we provide number 8, okay, if we provide 16 mm 8 bar and 2 20 mm bar, it will be also okay. Okay, it will be also okay. So you can go for it. For this column you can use 20 mm 2 bar and 16 mm 8 bar, and you have to arrange that. So what is the size of our column? If we right click here, size of our column is 15 into 21. Okay, also you have to maintain the distance between one reinforcement to another reinforcement shouldn't be more than 6 inch as per SA code. So to maintain that, here this is our column, and if I provide here 1 2 3 and 4, okay, and here 120 mm and here 120 mm, and here 16 mm to 16 mm and here to 16 mm. So I think it will be okay. Okay, because here we have 21 inch from that point to, they have a clear cover here, so from that point to that point we have 21 inch. Now for that 21 inch, we're leaving 3 inch as a clear cover, and you'll get here 18 inch. So they have 3 gap, and if I divide it with that, if we divide that value with this gap, then it will be less than 6 inch. So it's okay, same as from that side. So this side is also okay, because here 15 inch if we subtract the clear cover, then it will be 12 inch. So if we get that value as a 12 inch, just one thing I'll check here again. Okay, it's okay. Then what will be the value of it? Here 1 and 2, and also you have to remove that diop bar and then Stirrup diop bar, so it will be okay. Actually, in this way you have to maintain your minimum spacing or minimum and maximum spacing of that reinforcement. So it's done. Okay, we are providing 8 16 mm 16.5 plus 2 25. Done. Now we'll go for our Stirrup. So as per ACI code ACI 318, so what will be our Stirrup for column? Now here, first of all, you have to give here the max dimension of column and minimum dimension of column. So what is the max dimension? 21 inch, we know, and minimum dimension 15 inch. So we are providing that, and we have done it. And type of your structure, which types of structure? So if we consider intermediate moment testing frame, so you have to select from here. And if you provide here SMF, special moment testing frame, then you have to provide that option. Now what is the value of your yield strength of your steel? That is 7.25 kips. And leg number, so what is the leg number of your provided columns? If I just go here, and here if we provide one ring like that, it's known as 2 leg. And also if we provide here extra cross tie or tie, then it's known as 3 leg. And also if you provide some stirrup like that or tie like that, then it's known as 1 2 3 4 leg. So you have to provide it here. So I'm considering we'll provide like that, so I'm considering it will be 4 leg. And required steel bar, okay, so required shear bar. So what is the required shear bar? I'll go to ETABS, I'll close it, I'm going to clear it, and from here I'll go for shear rebar, shear reinforcing, then apply on that column. And here we are seeing here and here no required of shear reinforcement, but in top we required here also 0.5 to 3 inches core reinforcement required here. Average this for major, and this, the on reinforcement for major and on reinforcement for minor axis. So we'll consider the maximum one. Okay, so 0.5 to 23, this is the maximum. I'll provide here, okay, 0.53, it's okay. And dia of shear bar, we're going to use 10 mm dia of bar, and then dia of smallest long bar, so smallest long bar are 16. Done. Now you'll get here the detailing of your stirrup spacing. So what will be the value of left side reinforcement? 3.5 inch center to center as per code. Here 7.5 inch for middle portion of your column for ties as per code, and right side or just like that. So here if we have a column here, okay, if we have a column here, so this is your one part, and here you on another part, and here the provided reinforcement spacing will be more closed, and it is 3.5 here, 3.5, and middle 7.5 here, 7.5, and here also 3.5. And how much distance you have to provide 3.75 inch reinforcement? It's 21 inch. Okay, so L not or long distance from support in tie spacing as per code here, as per code. So what is that? This is 21 inch. So the distance will be 21 inch for that side also, for that side also. That's it. So in this way, you are able to design your column perfectly. So thank you very much.